So we might have seen parabolas in nature, from a rainbow to archways. The golden arches in McDonald's use parabolas. We see them over and over, including the way that a ball falls. So because of gravity, your acceleration and velocity of throwing a ball in the air towards or away from you, it will make a parabolic shape, whether it's basketball, football, any type of ball, depending on how high you direct it and how far forward you can throw it. So we do use parabolas all of the time. We use them in satellites. The focus point is actually what allows the signal to be picked up. When these signals are coming, that's these red arrows, it hits anywhere on the satellite dish and is eventually bounced to the focus point where the antenna is. So the focus point, as we can see here, is the antenna that's picking up the signal. When the signals hit anywhere on the dish, they will bounce to the focus point. We also use these for parabolic microphones. So this is why we can hear in a crowd full of 100,000 people, we can hear the players talking, because they point the microphone, which is where the focus point is, and the shape of the parabolic microphone will amplify whatever it's pointing at. So if it points at the players talking, it will pick up the players talking above all of the background noise. So that's a quick look at some of the ways we see and use parabolas. We're going to do a quick activity of how to fold tracing paper in order to show how the focus and directrix being equal will make the parabola. So when I was in school, I couldn't quite understand what the focus and directrix were, and this is a good way to look at it visually. So when you have a parabola, you will have a focus point, and the same distance to the vertex is what we call the directrix line. So this line and this line are going to be the same amount, and that holds true for anywhere on the parabola. So if I take this spot, the length of this line that's perpendicular to the directrix is always the same as the line to the focus point. And we're going to see how when the directrix line and the focus point are equal, it actually will form a parabola. Now these are not equal because I just made this one up. So here's what we're going to use. We're going to use tracing paper. We start by folding your tracing paper in half, really just to find the middle. That's the only reason I do that, because I want it centered. I will draw a focus point, and underneath that focus point I will draw a directrix line. And you know, the closer you make it, seems like it becomes a more narrow parabola. The further away, the more wide open. So when I'm done, I'm going to use my ruler, and if I was using a centimeter ruler, I would do every half centimeter. I have an inch ruler, so I'm going to mark every every quarter of an inch. So I have about 10 markings on each side. If you use this patty paper and a centimeter ruler, you'll have 13 to the right and 13 to the left. So I usually number them just so the students can keep track of each fold. So using quarters of an inch, I have 10 to the right and 10 to the left. So the first fold I will make is where the 0 would be, right here on top of the focus. And I'll actually work backwards. So I'll turn it around and I'll remark my focus just to make it extra dark. And the reason I turn it over is so that when I fold it, the numbers will be facing the right way. So here it is, and I will fold it. So what we want to look at is that focus point here. You can see it through the paper. You want to line it up right on the graph and fold it. This first fold will actually give us the vertex. So if we wanted to number this with half centimeters or a quarter of an inch like I did, you can actually get it, make it into a slightly more complex lesson, and you can actually find the equation of the parabola by having a y-axis. So the next step is I'll turn it over, and I'm going to line the number 1 on top of the focus point. So you can see that it's not right. It's right there. I'm going to lower it, lower it, lower it until it's right on top of the number line where the number 1 is. Then I'm going to fold it. I found that if I hold the back paper with my fingers, I can actually fold it pretty quickly. There's the second one, third one, and the fourth one all the way through 10. So when I turn the paper around, I actually have the parabola. You could start to see it, and you could see the folds, which are actual tangent lines, or the rate of change at that point, if you wanted to talk about the derivative and calculus. So now that I've done one side, I'm going to flip it over, and I'm going to fold the other side. So I'm going to line up number 1, fold it, line up number 2, and so on until I finish all 10. So now that I'm finished, I can beautifully see the parabola formed. The back side might even be a little nicer to look at. We have these beautiful symmetric lines on both sides and the parabola. If you wanted, students could trace the parabola using their pencil. And this is a visual way of showing how the directrix line, this line here, the distance to the vertex, let's say, is always the same distance as to the focus point. And this is true anywhere on the graph. So if I take this point here and go down, straight down, perpendicular to the directrix line, it's going to be the same distance as the point to the focus. And so if we did that anywhere, we would see it starts to make equal sides, kind of like an isosceles triangle. And as I mentioned or pointed out, each of these folds, if we look at them, they're actually a tangent line. So here's one of the folds. And it is a tangent line at one spot, meaning it's touching that one spot and giving the rate of change or the derivative. So you could get into that if you wanted to. Like I said, you could use half centimeters to label a y-axis and actually come up with the equation of a line. But this is a great way to see how the directrix to the parabola is always equal distance from the parabola point to the focus. And by folding the paper, we have equal distances, and we keep folding and folding, and it creates the parabola. So the directrix line and the focus are directly related to the making the parabola, and they are equal distances apart. So it's an easy, fun activity you could do to really show how a parabola is formed.